everyone, welcome to Gate Academy Global. So, how are you? First of all, let me know, am I audible? Am I audible to you? Is audio video clear to all of you? Tell me, am I audible? Let me know fast. Those who have joined the session, please confirm, am I audible or not? Because I'm going to give you a great announcement for all you guys for the GATE 2023 and 20. I think now the voice is clear. Okay. If you are not saying something, then let me identify by myself. Okay. Now I think audio is clear right now. I think audio is clear right now, everyone. So there is an announcement for you all guys. I'm launching computer network in the live app. Okay. That will be completely in Hindi medium. Hindi medium you can say means bilingual. Bilingual means like generally in a bilingual the teacher use both the languages, okay, Hindi as well as English, because of course we don't have a Hindi term for the English topic. Okay, so like every technical terms will be deal in English, but the concept will be delivered in Hindi. So I'm launching like computer network subjects on 9th of May. 9th of May at the rate 7 p.m. So here already it is written app plus YouTube. It means the like subject will start in the app, but parallelly it will be delivered in a YouTube. So there will be a 3 days free demo classes. 3 days free demo classes, so that still you are in a sleeping mode, I can awake you. Okay, I can just awake you. So if you are still in a sleeping mode, you just awake and go ahead, move ahead and start your journey. See, without having a proper guideline or proper guidance, we cannot do anything in our life. So somewhere for some subjects we require some help from the paid course, and in that situation it will help you out a lot. Okay, so there will be a 3 days free demo classes, okay, will be held on the YouTube channel. So just try to attend that 3 days free demo classes, and then you decide. If you think you are like okay with the computer network, then no need to go ahead. But if somehow you are thinking that I am lacking in this subject, so in that situation must join either the subject wise or the full length course, because still you are not late. This is the starting month of May, and you have still 8 months time to face the GATE 2023. So my dear friends, 8 months is more than sufficient to attempt or to prepare yourself for the GATE 2023 paper. So just start your journey. Are you getting my point or not? Just start your journey. Okay, so this was the announcement for you all guys. Okay, the subject will be taught completely in bilingual language, means Hindi as well as English. Okay, 9th May at the rate 7 p.m. and on like a CSIT YouTube channel, parallelly this subject will be held. Okay, CSIT YouTube channel, not in global. Since it is a bilingual language, that's why in a global channel we are not going to display these things. Okay, so you can attend the session in a GATE CSIT, GATE Academy CSIT YouTube channel. The same session which will be free for the 3 days. Which will be free for the 3 days. Okay, now let's start the subject. So in the previous session means in the last session we have talk about 2 different things. The first one is framing concept, and the second is like a type of delays in flow control protocol. So the continuing type of delay, we will start over here the stop and wait protocol, which is the first protocol under stop and wait, under flow control protocol. So continuing the concept which we have discussed in the last session, I will start the stop and wait protocol. Is that clear? So let's start stop and wait protocol. So in a type of delay or the parameters associated with the flow control protocol, we have talked about like different type of delays, like TF, transmission time of a frame, and TP, that is the propagation delay, T of propagation, T of processing means processing delay, and the last one is the T of ACK, that is the acknowledgement transmission time. So let's repeat this parameter once again, and then I will start the stop and wait protocol. And there are 5 to 6 problems that has been asked in the last 32 years from the stop and wait protocol. So now you can understand. If you will look upon the previous 10-year paper, so there are 3 questions asked from the stop and wait protocol. Okay, so let's try to revise these parameters or the type of delay associated with the flow control protocol, and then I will start the stop and wait protocol. Okay, so let's see over here. So TF basically means transmission time of a single frame. Means if this is the frame having a length L, so at the t is equal to 0 time, suppose this frame is staying at the system buffer. So how much time this particular frame will take to come from the buffer to the medium? This is called the transmission time of a single frame. So how can you calculate the transmission time? Then if the length of the frame is known and the transmission rate is given, then you can easily find out the transmission time of this particular frame. So see this one is nothing but transmission time of single frame. And how we can calculate this? So we can calculate this as a L upon R, where L is equal to what? Size of frame, and R is nothing but transmission rate. Let's take the example. So this is nothing but the transmission time of a single frame. Let's take an example. Suppose if the size of a frame is given as 100 bits and the transmission rate is given as 10 bits per second. What does it mean? It simply means on every second the system is transmitting how many bits? 10 bits. On each seconds the system is basically transmitting how many bits? 10 bits. So if the size of the frame is 100 bits, then how much time the system will take to transmit this particular frame from node to the medium? Suppose this one is the node. Okay, this one is the node. You can create the diagram like this. Suppose outside this there is a medium, or you can say the link. Either you can say medium or link, or you can say the channel. So this is basically representing a timeline. So there is a frame inside the buffer of this system, means at t is equal to 0 the frame is residing, this frame is having a length L bits. So at the time t is equal to 0 the frame is residing at the sender's buffer. So how much time this particular frame will take to come to the link. So this is nothing but transmission time of a single frame. So if at every second it is transmitting 10 bits, then how much time it will take to transmit 100 bits? 10 seconds. And how you can calculate this? You can calculate this like L upon R. So what is the L given? 100 bits divided by 10 bits per second. So the bits will be cancelled out and this one will become 10 seconds. Yes or no? Just like a velocity is equal to simple physics. Velocity is equal to distance upon time. We are applying this particular formula, which already we have learned in the class 8. We are applying the same formula that we have already learned in a class 8. Okay. So nothing big we are doing over here. Okay. So this is the very simple thing that we are using. Okay. So here L is the size of the frame and R is the transmission rate. If both are known, then you can easily calculate the transmission time of frame. Okay, of single frame. So this is the first parameter that we have discussed. The second parameter is like TP. That is the propagation delay. Here P is indicating the propagation time. Okay, P is indicating the propagation and T means time. So ultimately you can say propagation time, or time can also be sometimes said as a delay. Okay, so you can say propagation time or delay. Okay, and how you can define the propagation delay? The time taken by a single bit to reach from one point to the another point. Suppose two nodes are connected. Two nodes are connected by this particular link. Okay, so one is the sender, second one is the receiver. Okay, so this is the point associated with the sender and this is the another end point associated with the receiver. So basically how many times this particular single bit is taking to reach from one point to the another point is called the propagation delay. So simply how we can define the time taken by a single bit to travel from one point to another point in a given link. Okay, so how you can calculate the propagation delay over here? So my dear friends, if distance between these two links is given, okay, and speed of the signal is given, then we can easily calculate TP, that is the distance upon speed. Yes or no? Distance upon speed. So where D is equal to distance of link and S is equal to speed of signal. And generally the speed of signal is always equivalent to light, because signal is nothing but an electromagnetic wave and the wave always travels with the equivalent to the speed of light. Is that clear? With the equivalent to the speed of light. So TP is nothing but the D upon S. Let's take an example. Suppose the distance between two particular points is given as 100 kilometer, and the speed of the signal is given as 3 into 10 to the power 8 meter per second. Then what will be the propagation delay? The propagation delay will be calculated as distance upon speed. So distance is given as 100 kilometer divided by 3 into 10 to the power, or just you just take not 3, 2 over here. Okay, so 2 into 10 to the power 8 meter per second. So you can take over here 2 into 10 to the power 8 meter per second. Yes or no? So this is given in kilometer and this is given in meter. So what we have to do, just convert the kilometer into meter. So 100 into 10 to the power 3 meter divided by 2 into 10 to the power 8 meter per second. So meter will be cancelled out. So 2030. So this one will become 3. Yes or no? So ultimately this is going to be 1 by 2 into 10 to the power minus 3 second. So you can simply write 0.5 millisecond. So TP coming out to be here is 0.5 millisecond, because already we know that 1 millisecond 1 millisecond is equivalent to how much? 10 to the power minus 3 second. So there are something which you have to remember. Okay, so just see over here. See, whenever we are writing 1k means kilo. Whenever there is given 1k, k means kilo. It simply means 10 to the power 3. Please understand, we are not dealing with the digital electronics. Here we are dealing with the computer network. In digital electronics, 1 kilo basically represent 2 to the power 10. In digital electronics, whenever we are like dealing with the size of data or bits, so in that situation 1k basically represent 2 to the power 10. But in computer network, whenever there is given 1 kilo, it simply means 10 to the power 3. And whenever there is given 1 m, it means 10 to the power 6. So whenever something will be given in a mega, then we have to convert this into this form, 10 to the power 6. And whenever there is given 1 giga, it means 10 to the power 9. So please remember these things. Note it down. While dealing with the computer network subject, we will apply these particular things. Okay. So similarly, 1 milli simply means 10 to the power minus 3. And already we know these things from the you can say operating system. In operating system, we use basically these terms: milli, micro and nanosecond. Okay. So 1 milli basically means 10 to the power minus 3, and 1 micro basically means 10 to the power minus 6, and 1 nano basically means 10 to the power minus 9. Okay. So whatever the parameter is given in the form of milli, micro or nano, you can convert like this. And if the parameters are given in the form of kilo, mega or giga, you just convert it like this. Okay, is that clear? So remember these things. So apart from this, we have learned about the two different things. One is the processing time. Processing time means what? Whenever the receiver will receive a packet, definitely the receiver will send the acknowledgement packet to the sender. But before creating the acknowledgement packet, the receiver has to process the incoming frame. So after processing the incoming frame, only then the receiver can create an acknowledgement frame. So the time taken by the receiver to process the incoming frame and creating corresponding acknowledgement frame is called the processing time. And once the acknowledgement frame is created, definitely first of all the receiver will transmit the acknowledgement frame, and then that particular acknowledgement frame will reach to the sender side. Means the transmission time of acknowledgement frame will also be considered. Okay, See, in general, the size of the acknowledgement frame are very, very less. I have also given you an example. Suppose one train is traveling from Kolkata to Delhi, and in that particular train there are 2000 number of passengers. So once that train will reach from Kolkata to Delhi, so definitely the controller available in Delhi will inform about this, that this particular train has been received. So my dear friend, to inform like a delivery of this particular train which reached to the Delhi, will the controller send another train to the Kolkata controller? No. Only one passenger are sufficient to inform this particular situation. Only one passenger is sufficient to inform whether the train has been delivered or not. Yes or no? So definitely whenever the receiver is acknowledging the reception of incoming train, only one passenger is sufficient. So definitely the size of the acknowledgement frame will be very, very less in comparison to the incoming frames. And that's why sometimes we ignore the transmission time of acknowledgement frame. If the size of the acknowledgement frame is very, very less, then we can ignore the transmission time of acknowledgement frame. And these things will be given inside the question. You don't have to assume these things by yourself. All the informations will be given inside the question. Okay, so we will see each and everything one by one. Just don't worry. Okay, so just see over here. The first protocol that comes under flow control protocol is the stop and wait protocol. Stop and wait protocol. Okay, stop and wait protocol. So just see over here. So why the name was given as stop and wait protocol? Please try to understand. See, the stop and wait protocol basically means send a frame, then stop, and wait for acknowledgement before transmitting the next frame. Before transmitting next frame. Okay, now I hope you are able to understand why the name was given as stop and wait. So simple meaning of stop and wait is send a frame and wait for the acknowledgement, and once the acknowledgement will be received, then only send the next frame. Are you getting my point or not? And that's why the name was given as stop and wait protocol. So in this situation we have to calculate two different things. In this situation, in the case of stop and wait protocol, we have to calculate two different things. First one is the utilization of channel, and second one is the throughput of channel. Okay, so here basically we need to calculate two different things. One is called utilization of channel, or you can say the link. Yes or no? Either we can use the term channel, link, or we can use the term like medium. Okay, so first thing that we have to calculate in case of stop and wait protocol is the utilization of channel, or you can say the link. The second thing is throughput of channel. Okay, throughput, or you can say effective bandwidth. So there is a reason for everything. If I am saying effective bandwidth, why I am saying effective bandwidth? There is a reason for everything. We will understand step by steps. Okay, so either you can use the term throughput, or you can use the term effective bandwidth. So what is the bandwidth actually? Bandwidth is nothing but the data rate, transmission data rate. So please note it down. Bandwidth is nothing but transmission data rate. Transmission data rate. So my dear friends, whenever bandwidth will be given, it will be always given in the form of RBPS. So R is nothing but the transmission rate, and BPS basically represent bits per second. Got it? BPS. So whenever they have given a small BPS, it simply means bits per second. These are the general notation, and we have to remember the general notation. Whenever the small BPS given, it simply means bit per second, and whenever capital BPS is given, it simply means bytes per second. So please remember these things. Okay, because this will help you a lot while solving the numerical. These things will help you while solving the numericals. Is that clear? So let's come to the stop and wait protocol. So what we have understand about the stop and wait: send a frame, stop and wait for the acknowledgement, and as soon as the acknowledgement will receive, then send the next frame. That's why the name was given as stop and wait protocol. Okay, so let's start. Suppose there are two nodes, one is the sender and second one is the receiver, which are connected through a link, which are connected through a link, and these are the timeline. These are the timeline. Okay, these are the timeline. So definitely this is nothing but a sender and this is nothing but the receiver. Okay, see, the transmission rate of the sender is R1 and the transmission rate of the receiver is R2. Just assume the transmission rate of the sender is R1, because most of the time the transmission rate of the sender and receiver are same. But if it is given inside the question that the transmission rate of sender and receiver are different, then you have to follow that particular instruction, and that's why I am taking a general form. Suppose the transmission rate, that is the bandwidth. Either you can say the transmission rate or you can use the term bandwidth. So suppose the transmission rate of the sender is the R1 BPS and the receiver is the R2 BPS. Okay, R2 BPS. So what is the concept of the stop and wait? If sender have a frame to transmit, suppose this is the frame the sender have. What is the length of the frame? L bits. So whatever it is given, either it can be given in the form of bits or it can be given in the form of bytes. So please take care of those things. If it is given in bits, then let it be in bits. If it is given in bytes, then convert the bytes into the bits. Okay, these things you have to basically take care while solving the numericals of the gate previous year. Okay, so suppose this is given in bits. So this is nothing but a frame the sender have to transmit. So suppose initially this frame means at the time is equal to 0, at the time t is equal to 0, suppose this frame reside inside the sender's buffer, So what will happen? This is residing at the sender buffer at the time t is equal to 0. Now how much time this frame will take from the sender buffer to come to the link? This is nothing but the TF time. Already we have seen this is nothing but the TF time. So after the TF time, this frame will come to the link. Means at the t is equal to 0 it was in buffer. Now at the t is equal to TF, the frame has reached to the medium. This is nothing but a link, or you can say the medium. So after TF time, the frame is come to the medium. Now just imagine this is the last bit of the frame. Yes or no? This is the last bit of the frame. And what is the definition of propagation delay? The propagation delay can be defined as the time taken by a single bit to reach from one point to the another point. So just think about this particular bit, this particular last bit. So after how much time this bit will reach over here? So this is nothing but the TP. So after TP time, this particular last bit will come from here to here. It means the entire frame would get delivered into the receiving point. Yes or no? The entire frame will come to the buffer of receiver. Are you getting my point or not? Or are you able to visualize this situation or not? If this particular last bit will come to the end point of the receiver, means the entire frame will be delivered to the receiver. Deliver means will come to the receiver's buffer. Is that clear? So after the time t is equal to TF plus TP, this frame is delivered to the receiver. It is delivered to the receiver. Now analyzing the receive frame, what the receiver will do? It will create an acknowledgement frame. So just analyzing this particular frame, it will create a acknowledgement frame. So suppose this is the acknowledgement frame. And size of this acknowledgement frame is, just assume L of ACK. L means frame size, ACK means acknowledgement. So here L of ACK basically represent size of acknowledgement. ACK means acknowledgement frame. Okay, so L basically represent the size of frame, and what kind of frame? Acknowledgement frame. Okay, so analyzing incoming or the receive frame, what the receiver will do, it will create a it will create an acknowledgement frame. So between this it will take some time. So suppose this is the processing time. After processing this frame, means processing this frame and creation of the new frame will take some time. So this is the processing time. So once the acknowledgement frame will be created, what the receiver will do? It will transmit this particular frame. First of all, it will transmit this particular frame into the medium. So how much time this frame will take to come into the medium? So that is nothing but the T of ACK, means transmission time of the acknowledgement frame. So after this time, this frame will come to the medium. Now just think about the last bit of this particular acknowledgement frame. This is the last bit of the acknowledgement frame. So how much time this bit will take to come from this point to this point? This is nothing but TP, propagation time. So after TP time, the acknowledgement frame will reach to the sender's buffer. So my dear friends, how much total time the sender is taking to deliver a single frame successfully to the receiver? That is the TF, TP, T of processing, and then T of ACK, and then TP. Okay, yes or no? So here what we are identifying total time taken by sender to deliver single frame successfully is TF plus TP, and then T of processing, and then T of ACK, and then again TP. Yes or no? Then again TAP. Means this is the time taken by a sender to deliver the frame from sender to receiver, and after that the processing will be done. After that the acknowledgement frame will be transmitted, and this is the time taken by the acknowledgement frame to come from receiver to sender. So this is the total time taken by a sender to deliver a single frame successfully. So my dear friends, how you can calculate the TF from here? So please remember these things, because later on I will use this. So here TF is nothing but size of the frame divided by transmission rate, that is the R1. What is the means who will transmit the frame? Sender. Who will transmit the frame? Sender. So you have to use the transmission rate of the sender. And who will transmit the acknowledgement frame? That is the receiver. So the size of acknowledgement frame, that is the L of ACK divided by R2, which is the transmission rate of the receiver. So here R1 is the transmission rate of the sender, because the sender is transmitting a frame, and R2 is the transmission rate of the receiver, because only the receiver is transmitting the acknowledgement frame. So while calculating, please remember these things. Whether you are calculating the transmission frame transmission time or the acknowledgement transmission time, please remember like which parameter you have to use, R1 or R2. Is that clear? So here we have calculated the total time taken by a sender to deliver one frame successfully. Now we are going to calculate utilization of channel. So before calculating utilization of channel, just tell me what is the meaning of utilization. Because we use the same term in operating system also. Yes or no? In operating system we use the same term, utilization of CPU. So the reference can be changed. There in operating system we are calculating the utilization in the reference of CPU. And here in the term in computer network we are calculating the utilization in the reference of channel, or you can say the link. in the terms of link. So in general, how you can define the utilization? Can anyone tell me? Yash. Okay, Yash. Thank you. Thank you. So how can you define the utilization? Utilization means, just take an example. Once you will try to connect anything with the real life, that things will remains in your mind for a longer period of time. Yes or no? Once you will try to connect any concept with the real life events, then there is a very rare possibility that you are going to forget. You are going to forget anything. Okay, so please try to understand the real example. Suppose I have assigned you total 10 hours to study physics, or just take to study computer network. I have assigned you total 10 hours from 9 a.m. to 7 p.m. that you have to study the computer network. Now, how you have utilized your time? Just try to imagine. Suppose you have spent 4 hours to study the computer network, 2 hours to study the TOC, and 2 hours to study the discrete mathematics, and remaining 2 hours you have spent for sleeping. So my dear friends, once I will ask you your utilization, what should be your utilization? What should be your utilization? See, I have told you to study the computer network. What other subject you are studying, that is not my concern. Are you getting my point or not? Those was not my concern. If you are doing something in my reference, then only I will count your utilization. Are you getting my point or not? So how much time actually you have spent for studying the computer network, that is my concern. So out of 10 hours, you are spending only 4 hours to study the computer network, and that's why your utilization will be what? Your utilization will be 4 upon 10. Whether you are studying the TOC, DBMS, discrete mathematics, that is not my concern. So I will calculate your utilization as 4 by 10 because you have only spare your 4 hours time to study the computer network. Is that clear? So similarly, here we are trying to calculate utilization of what? Channel. Utilization of channel, or you can say channel, or you can say link. In simple way, you can say link. Are you getting my point? Utilization of link. So basically, in a computer network, what is our objective? In a computer network, our objective is, in a computer network, our objective is to establish what? Established data communication. Yes or no? Our objective is to establish the data communication, and between sender and receiver, two kinds of packets are migrating. Please try to understand. Between sender and receiver, what kind of packets are moving? Two kind. One is the frame, second one is the acknowledgement. So between sender and receiver, two type of packets are migrating. One is frame, and the second one is acknowledgement frame. My dear friends, will the acknowledgement frame contain data? Means in which packet that actual data is contained? Can you tell me? Anyone? So only the frame will have a communicating data, not the acknowledgement frame. Acknowledgement frame is just a confirmation frame, not a data frame. Okay, so whenever we are talking about acknowledgement frame, so this is just a confirmation frame, not data frame. And whenever we are saying the frame, so this is nothing but a data frame, you can say. This is nothing but a data frame. So since our objective is to establish the data communication, our objective is to establish the data communication. So the utilization will always be calculated in the reference of data frame, not in the reference of acknowledgement frame. This is just like you are spending your time to study the TOC, not computer network. So what other subject you have studied, that was not my concern. How much time you have spent for the computer network, that was my concern. Are you getting my point or not? So we will always count the utilization in the reference of data frame, because we want to establish the data communication. Not for the acknowledgement frame. So this is the first thing. Where we are able to understand the reference. Now let's try to understand the meaning of utilization. Okay, so to understand the meaning of utilization, please try to consider the real life example, that is the roadways. So all of us in a daily life cross through the roadways. Suppose if you are going to your college from your home or from your hostel, so definitely you will go through the roadways. Are you getting my point? So just think about the roadways. Okay, okay, so this is the roadways which connects two different stations. Suppose this is the station S1 and this is the station S2. Okay, this is the station S2. Now suppose one bus has started departing from the station 1. Okay, now once this particular bus will reach to the station 2, what the station 2 will do? What the station master is staying over here. Suppose there is a station master sitting over here. So once this particular bus will receive by the station 2, what this station master will do? It will send a acknowledgement for the reception of this particular bus. So the bus which is coming from S1 to S2 will have lots of passenger inside this. So suppose there are 1,000 number of passenger available inside this bus, and once this bus will get delivered to the station 2, so definitely the station master staying over here will confirm about this delivery to the station master S1. Yes or no? So will it send another bus to just make this confirmation? No, because only single person walking from here to here is sufficient to just give the confirmation about this delivery. Yes or no? Station 2 need not to send another bus to just give the confirmation about this delivery. Only one passenger is sufficient. He will just sit over the motorcycle and will come over here and just give the information. So definitely this is acting like a acknowledgement frame, and this is acting like a data frame. Yes or no? So once we are thinking about the acknowledgement frame, so what you can see, the size of the actual frame means the number of passenger in an actual bus is 1,000, and for just giving the delivery of this bus, the person we are sending is 1. So in comparison to this, the size of acknowledgement frame is very less. So only one passenger is sufficient to give the confirmation of delivery. Okay, so now just think about this roadways. Okay, so the roadways having a size from here to here, the roadways having a size how much? 100 meters. Between the station S1 and S2, and at a particular moment of time, how much part of the roadways that we are using over here. So suppose this is the 20 meter size. So whenever this bus will move, or wherever during the movement, wherever this bus will stay, it will only consume only 20% area of the total roadways? Yes or no? During the movement of this particular bus in this roadways, how many space this bus will consume? Whatever the size of this particular bus is, yes or no? And that is nothing but the 20 meter. So only 20% area, only 20% space of roadways will be utilized by sending bus, and in a computer network we use the term frame. Yes or no? In a computer network we basically use the term frame in place of bus. Yes or no? So this is basically representing the utilization of here this is the roadways, and in computer network we use the term channel, or you can say link where in computer network. So this is the real life example, and this is once you will try to connect these things with the computer network. So this is nothing but the like a channel between the sender and receiver. So whenever we are sending a data frame, how much space it is utilizing at a particular moment of time, that basically determine the utilization of channel. So my dear friends, what is the size of this particular frame in a computer network? That is nothing but, in terms of time, that is nothing but the TF. What is the size of frame in terms of time? That is nothing but the TF. We will never consider the size of acknowledgement. How much space this acknowledgement frame is consuming during the movement. We are not going to consider this, because this is not a communicating frame. This is just a confirmation frame. Are you getting my point or not? So we are not going to count the space occupied by the acknowledgement frame in channel. Are you getting my point or not? Because the reference is given to the communicating frame, not the acknowledgement frame. The reference is given to the communicating frame because in a computer network we basically try to establish the data communication. So the reference is, suppose in an example I have told you how much time you are spending for studying the computer network. That is my concern. What you are doing with the other subject during that particular 10 hours, that is not my concern. So studying a TOC is similar like consuming a space due to the acknowledgement frame, that we are not going to count over here during calculating the utilization of channel. So how we can calculate the utilization of channel? So out of total part of the channel, means out of the total time, how much time you are consuming for transmitting the data frame. In that way we will calculate the utilization of channel. So finally how you can calculate the utilization of channel? So the total time, that is the TF plus TP, means time taken by a single frame to deliver successfully. Is nothing but TF plus TP, T of processing plus T of ACK and plus again TP. So out of this total time, how much communicating frame we are sending? That is only the TF. So this is nothing but utilization of channel. So out of this total time, how much space of the channel we are utilizing by the communicating frame? That is the TF. We will never add T of ACK over here, because acknowledgement frame is not a communicating frame. So the time or the utilization will always be counted in the reference of communicating frame. That is the TF. So the utilization of channel will become this, and we can represent the utilization of channel by this notation, by eta. So later on, whenever I will use the term eta, it simply means utilization of channel. Is that clear? So in this formula, suppose if T of processing is given as tending to 0 and T of ACK is also tending to 0. Okay, suppose these two parameters are 0, then the utilization of channel will become how much? TF upon TF plus 2TP. Yes or no? The utilization of channel will become this. If the processing time of a frame and transmission time of the acknowledgement are given as tending to 0, or you can say tending to 0, or you can say negligible, okay, negligible, then the utilization will become equivalent to this. So this is the formula we have calculated in case of stop and wait protocol. Stop and wait protocol. Okay, so I'm giving you an example, just try to find it out. Okay, so suppose the example is given like this. Suppose the size of the frame is given as 1000 bits. Okay, and the bandwidth of the sender is given as, bandwidth means data rate of the sender is given as like 10 to the power 6 bps. Okay, and distance between sender and receiver is given as 10 kilometer, and the speed of the signal is given as 2 into 10 to the power 8 meter per second. Okay, assuming T of processing and T of ACK negligible, find utilization of channel, if stop and wait protocol is used. Okay, wait protocol is used. Suppose that this is the question given, is used. Suppose this is the numeric type question and we have to find out the utilization in percentage. Okay, so how can we do this? See, the T of processing and the T of acknowledgement is given as negligible, means 0. So simply we have to use this particular formula, and to use this particular formula, first of all we need to find out TF and TP, then only we can apply this formula. Okay, so how we can find out the TF? The transmission time of the frame is nothing but the frame length divided by bandwidth, and the frame length is given as 1000 bits, and the bandwidth is given as 10 to the power 6 bps means bit per second. So the bits will be cancelled out, and here this one will become 3. So this is 10 to the power minus 3 second. So you can write 1 millisecond, yes or no? Similarly, find out the TP. So TP is nothing but distance upon speed. So the distance is given as 10 kilometer. Convert the kilometer into meter. So this one 10 kilometer means 10 into 10 to the power 3 meter, and divided by speed given as 2 into 10 to the power 8 meter per second. Yes or no? So just cancel it out. Okay, so here this one will become 10 and 30. So this one will become 4 number of 0. So finally this is going to become 1 upon 2 into 10 into 10 to the power minus 3 second. Yes or no? So this one will become 1 upon 20 millisecond. Got it? 1 upon 20 millisecond. Is that clear? Now we have both the parameter TF and TP. Now we can calculate the utilization of channel. So the utilization of channel will become TF upon TF plus 2TP in case of stop and wait protocol. If when you can write this formula, if T of processing is tending to 0 and T of ACK is also tending to 0. In this situation we can write this formula. So put the value of each parameter. So this is the 1 upon 1 plus 2 into 1 upon 20. So this is the thing. This is in millisecond and this one is also in millisecond. So the millisecond will be cancelled out. So here this is the 10 So finally 1 upon what you can write, this is the 11 upon 10. So this one is 10 upon 11. So this one is how much? Once you will calculate this, you are going to have a 99.9 percentage. Yes or no? 99.9 percentage means almost the channel will be utilized. Almost the channel will be utilized. See, my dear friend, this is the answer you can put. This is the answer you can give. But try to understand one thing. See, the utilization of the channel will be either 0% or it could be maximum. How much? 100%. Yes or no? The utilization of anything could be either 0% or it could be maximum 100%. See, if we are sending none of the frame through the medium, then in that situation the utilization of the medium or the channel will be 0%. Means during the 1 hour, if we are not sending any frame, so in that 1 hour, what will be the utilization of the medium, or you can say channel? That will become the 0%. But when it will become the 100%, please try to understand. See, between the sender and receiver, if you are sending a frame like this, suppose entire channel has been filled by the frame, So in this situation, what you can say, the utilization of channel is almost equivalent to what? 100% between sender and receiver. If entire channels are filled with the bits, and bits means frame. Are you getting my point or not? Because frame contain the bits. So if the entire channels are filled by the number of frames, in that situation the utilization of a channel will be almost equivalent to 100%. See, utilization of anything, if you remember the things in 9 and 10th, utilization of any machine can never be 100%. Like just see, in your car, whenever you like purchase a car, okay, so there is written the maximum speed limit is 180 km per hour. Can you ever reach to the 180 km per hour? No. That is the maximum value which is given, and we cannot reach over there. We can almost reach to the there, but we cannot exactly reach over there, because once you will try to reach over there, you will stuck in a accident. So utilization of machine or any machine can never be 100%. You can say it can be almost 100%. Are you getting my point or not? So in this situation, the utilization is 100%. And suppose if you are not utilizing a channel, what does it mean? If the sender is not sending any data frame, then in that situation the utilization of the channel will become 0%. So the utilization of channel could belong to from 0 to 1. Is that clear, everyone? So in this situation we have calculated the utilization of channel. In case of stop and wait protocol. So in tomorrow's session we will think about the throughput, and we will try to analyze the stop and wait protocol. So there are two topics which has been left. One is the calculation of throughput. The second one is the analyzing the stop and wait protocol completely. Okay, and then we will try to solve some previous year problems. Okay, so I will take like 3 to 4 numericals associated with the stop and wait protocol, and will discuss about the solution, so that gradually you can feel the confidence. So my dear friends, from the tomorrow onwards I am starting the GATE previous year numerical. So if you are still serious about your GATE exam 2023, then never miss any single lecture. And if you are new in this platform, GATE Academy Global CSIT, then you can join our group. Okay, so what you can do, this is my telegram number. If you want to join the group for English medium, you can just write me a text. This is my number, 9264954515. So this is my personal number. What you can do, you can just text me like, hi sir, okay, GATE English. Immediately I will join you inside the group. So I have created a group for the formal discussion in the name of Gate Academy Global CSIT. Global CSIT, I have created a group so that all the students who are comfortable in English can communicate with me and with all the like Gate Academy faculty. So those students who are connected with us through the YouTube and feels comfortable in English, they can join our group Gate Academy Global CSIT. There we all the faculties are there in this group. So whenever you have a doubts in any subject, you can either put your doubts in a group or you can personally text me. Definitely, my dear friends, within 24 hours or maximum 48 hours, I will give you the reply. Not only me, every teachers of this platform will give you the reply. It hardly matter whether you are a paid student or you are a YouTube student. It hardly matter, because for us all the students are equivalent. Okay, all the students are equivalent and keep equally importance. Okay, so because in GATE 2022 result we have seen there are many students who are only followed our YouTube channel and secure very good rank. One of the student recently texted me, sir, I got the admission in IIIT Hyderabad, which is one of the premier institutes in India. Once you are selected in IIIT Hyderabad, you can expect minimum salary of 15 to 20 lakhs once you will pass out your MTech. And that student was only connected through the YouTube. So that's why I have told you, it hardly matter whether you are connected with us through the YouTube or paid course. Okay, ultimately our objective is to learn the subject in a proper manner, so that once we will appear for the exam, we can make a history. Okay, so this is my Telegram number. If you have any doubts regarding the subject, because see, once you will join the group, what will happen, all the time we all faculty basically give the class information and there will be some announcement. Okay, whenever the announcement will be there, it will be given inside the group. And we generally, whenever there is a vacancies or opening are there, then we also intimate those things through the group. And most importantly, the groups are created only for the discussion, doubt discussion. Okay, so if you want, you can join us through this particular number. Okay, and you can have all the informations related with the class, doubt, and upcoming exam and vacancies. Okay, so that's all about this session. We will again meet tomorrow sharp at 7 p.m. Okay, so bye, take care, Jai Hind, everyone. Bye.